All right, hi everybody. Welcome back to this section 6.1 video where we are reviewing power series and their properties. And in this video, we're going to go over adding power series into one power series. And that's going to require the idea of index shifting if you have not seen that before, and peeling off terms. And the goal is to write and combine these power series into one power series. So when we do this, we want them to have the same starting index. So both starting out at like 1, n equals 1 or n equals 3, and they're both starting out at x to the n. So that's always our goal. So let's take a look at what we have to work with. So we have the power series starting at n equals 2, n times n minus 1, c sub n, x to the n minus 2. So a couple things I could notice here first is that this first term starts at n equals 2. So that's our starting index. And our x variable is x to the n minus 2. So it's not x to the n. Okay, and then when I talk about first term, this is what I am describing, the first term. And so let's look at the second term. This second term starts at n equals 0. So they have two different starting indexes. And x to the n plus 1, we needed to start at x to the n. Okay, and this would be the second term we are looking at. Okay, so when we want to combine these, there might be more efficient ways to do it. But in this video, I want to kind of go over some basics of working with the power series, like shifting an index, peeling off terms. Okay, so you might find a quicker way to do it. Like it's not always just one way to do it. But here I want to go over like the basics so we have a couple tools in our pocket and we know how to maybe manipulate a couple of things. So we first want to get them at the same starting index, like for step one. So, let's go ahead and try that out. So, solution. Okay. Uh, and we want to get them the same starting index. So what we're going to do, let's focus on this first term here. Uh, we'll get around this by peeling off. I'll put quotations around peeling off because it's not the actual phrasing, but that's kind of what we like to think about it as. We'll peel off the first series, okay? The first term. Okay, so we're trying to get the same starting index. So what we're going to do is peel off the first term of the series to get it up to n equals 3. So what do I mean by that? So let's just rewrite that power series. N equals 2 to infinity, n times n minus 1, c sub n, x to the n minus 2. So maybe I can annotate a little bit more here. I'll say like first, let's get maybe like step one first, let's get same index. Maybe that might help for annotation. But yeah, so we're looking at this first term. All right, we want to peel off. We want to get the same starting index out at n equals 3 for both of these. Okay, so what we can do is peel off essentially. So I'm going to peel off the n equals 2 term here. So if I peel off the n equals 2 term, that means I'm plugging in n equals 2 for n. So this would be like 2 times 2 minus 1, c2, x to the 2 minus 2. And I'm only peeling off the n equals 2 term. So this would be like n equals 3 to infinity now. And it's just the same series. Okay, and this is n equals 2. Okay, so couple things work out well. The x to the 2 minus 2, that becomes x to 0, which is just 1. So what I'm left with is just 2c2 plus the series n minus 3 to infinity, n times n minus 1, c sub n, x to the n minus 2. Okay, so, you know, that's the first term, okay? We peeled off to get n equals 3. We want to get the same index n equals 3 for both terms. So what we can do now is get that second term, get the second term to be n equals 3. So let's do that. And the way to do that is index shifting. So here's what I'll say. What we can do now is shift the index of the second series so that it will start at n equals 3. Okay, what does index shifting mean? Okay, so let's rewrite the power series down here. N equals 0 to infinity, c sub n, x to the n plus 1. And so when we power shift, right, we're trying to get it to n equals 3. So that means when we power shift, our new index is going to be 3. So what that means is we add 3 to the index. But if we add to the index, what that means is we subtract 3 from every n inside of the power series. So this would be like n minus 3 plus 1. So we subtract 3 from every n. And so if we simplify this, our new power series would be c to the n minus 3, x to the n minus 2. So great, we are now both having the same starting index of n equals 3. Okay, so why does that happen, right? If you haven't seen this type of index shifting before, shift the index. It's a very neat tool to have on the power series if you can understand how it works. So what is the reason? The reason has to do with algebra. Okay, so the reason we do this is like algebra and sort of balance in a way that we're adding 3 to the index. So we have to take away 3 from wherever n is in the series. Okay, and just be careful that, you know, all the ends in the series have to change. Okay, so just be careful there. That whenever you index shift, all the ends are being affected. So we did a couple things in the solution. Okay, so what I want to do is recap a little bit about what we did. So let's do that. To recap, okay, we have found that our beginning series that we're given at the beginning of this problem, okay, just rewriting what we were given, we turn this into 2c2 plus the series n equals 3 to infinity, n times n minus 1, c sub n x to the n minus 2, plus the series n equals 3, both are starting at n equals 3, so we are in good shape, x to the n minus 2. Okay, so that's what we've done so far. Started at the same index. Okay, so we have accomplished our goal of having the same starting index at n equals 3. Okay, so that's good. Um, but what's the other component that we want to have? We want to have our x to be to the n, not x to the n minus 2, like we have right now. So the next thing we have to do is get x to the n. Okay, so here's what I'll say. But we don't have the series at x to the n. Okay, because what do we have? We have x to the n, but these are x to the n minus 2. Okay, so that doesn't work. Okay, but we already learned a tool that will help us sort of change around some n's. So we're going to use index shifting to make these into x to the n. Okay, so to do this, last step, we'll shift both series to turn the powers to x to the n. Okay, so to get x to the n minus 2 into x to the n, we need to index shift. So we would need to add 2 within the series and subtract 2 from the index. Okay, so let's take a look at our series. So we have 2c2 plus the series n equals 3 to infinity, n times n minus 1, c sub n, x to the n minus 2, plus a series n equals 3 to infinity, c sub n minus 3, x to the n minus 2. Okay, so within the series, I need to add 2 to every n. And if I'm doing that index shifting, that means I need to subtract 2 from the index. So this turns into 2c2 plus the power series n equals 1, n plus 2 times n plus 2 minus 1, c to sub n plus 2, x to the n plus 2 minus 2, plus n equals 1, c sub n plus 2 minus 3, x to the n plus 2 minus 3. Okay, so what am I doing? I'm plugging in n plus 2 wherever there is an n. Okay, that's part of our index shifting. So we do that because we'll end up with the x to the n. So if I simplify, this would be 2c2 plus the series n equals 1 to infinity, n plus 1 times n plus, excuse me, n plus 2 times n plus 1, c sub n plus 2, x to the n, because the 2 and the 2 would cancel out. So we have our x to the n now, plus the series n equals 1 to infinity, c sub n minus 1. 2 minus 3 is negative 1. X to the n, I think I have minus 3 here. I don't know why I wrote that, but it should be minus 2. But those cancel out. Okay, and then I'm left with just x to the n, and we're starting at the same index. So everything worked out great. So since the series are now like terms, meaning same index n equals 1 and same power x to the n, we can combine. So remember, our goal from the beginning was to combine into one power series. Okay, that was our goal. So everything is the same now in terms of index and power, so we can combine them now. So what this would be is combining the two power series, the 2C2 stays the same. They would both have the series n equals 1 to infinity, and we would just combine them two. So n plus 2, we're literally just going to add them. N plus 1, c sub n plus 2, x to the n plus c sub n minus 1 x to the n. Okay, we could even simplify this a little more. They both have x to the n. We can factor that out, and we will be left with 2c2 plus a series n equals 1 to infinity of n plus 2 times n plus 1, c sub n plus 2 plus c sub n minus 1 times x to the n. And then that is our answer. So this is a single power series now. Okay. Which has x to the n as the power. Okay, so that is an example of adding power series and index shifting, peeling off to get them to the same uh, combined power series. So just a couple things that we could say about this as we wrap this up, that it doesn't really matter what index we start out with. Could be 1, it could be 2, it could be 3, could be 0, you know, n equals 0, 1, 2, 3, etc. What we just don't like in power series solutions is if it's negative. All right, we just don't like it when the starting index is negative, and the smallest we want it to be is n equals 1. But okay, so that is an example of index shifting, combining, peeling off. So I wrote a lot of annotation just so like it's just not me talking about what we're doing and just a bunch of random work. So I try to annotate as much as I can. So for your solutions, you don't need to do all this. That's just me taking it the extra detail. And for this as well, I kind of just took a different route in doing it, like peeling off and then index shifting. Maybe you could use a different method. I just want to give us both ways of like peeling off and index shifting. So you have both of these resources if you want to use them, okay? But I'm sure there's a quicker way to do this that you might find. Maybe you index shift first and then take it from there. But yeah, this is just an example that helps us like get going on solving a differential equation. But yeah, thank you for watching, and then I'll see you in the next video. Take care.